Hello everyone, welcome back to our channel. Today we are going to cover all types of questions of projectile motion from the ground. So if you want to master projectile motion completely, watch this video till the end. So before I start solving this, if you're preparing for JEE or NEET and you feel stuck with concepts, strategy, revision planning or question solving approaches, then you can check out Pracbee. At Pracbee, students can book personalized one-to-one mentorship sessions with experienced mentors to get individual guidance based on their own strengths and weaknesses. Now with that said, let's get into the question and see the smartest way to solve it.
So here first let us see the projectile from the ground. And let me quickly write down the important formulas that we have to keep in our mind. So if we are throwing a particle with the initial velocity u and the angle of projection is theta. So the time of flight is 2u sine theta by g, and the maximum height attained by the projectile will be u square sine square theta by 2g, and the range is u square sine 2 theta by g, and maximum range is u square by g, and it happens at theta to be 45 degrees. And the equation of trajectory, so there are two forms. So the first form is y is equals to x tan theta minus x square upon 2u square cos square theta. So the g is also there, gx square upon 2u square cos square theta. So this will be theta. And the second form will be y is equals to x tan theta 1 minus x by r, where r is the range of the projectile. And if we want to find the velocity, so velocity will be u cos theta I cap plus u sin theta minus gt j cap at a particular time. And if you want to find the position vector, that will be u cos theta t I cap plus u sin theta t minus half gt square j cap, right? So these formulas we have to keep in our mind. Now let us see some of the questions, right? So the particle moving in a circle of radius r with a uniform speed takes time t to complete one revolution. So time, right, so is given for a uniform circular motion. If this particle is projected with the same speed at an angle theta to the horizontal, the maximum height attained by it is equals to 4 times r. So h max is given as 4 times r, where r is not range, it is the radius of the circular path, right? The angle of projection is, so let us first find the speed of projection. So we have given time period for the circular motion. So time is distance upon speed. Distance will be 2 pi capital R upon u. So u will be 2 pi r by t. So this we have to use. So h max is u square sine square theta by 2g is equals to 4 times r, and u square can be written as 4 pi square r square by t square times sine square theta by 2g, that will be equals to 4r. So 1 r will get cancelled out. So from this we can find sine theta. So sine square theta will be 2g t square divided by pi square r. Now let us take the root of this. So theta will be sine inverse 2g t square divided by pi square r raised to power 1 by 2. So option 1 is the right answer. Now let us see this question. The maximum height reached by the projectile is 64 meters. If the initial velocity is halved, the maximum height of the projectile is. So we know that h max, suppose if we're throwing the projectile in the vertically upward direction, it is basically uy square by 2g, where uy is the velocity in the upward direction. Now if the velocity is halved, since h max is directly proportional to square of the velocity in the vertical direction, right? So we can say if we halve the velocity, the h max will become 1/4. So 64 divided by 4, that will be 16. So 16 is the answer of this question. So in this case, we are projecting in the upward direction. There is no horizontal component. Let us see this question. The angle of projection for a projectile to have same horizontal range and maximum height is, so range and maximum height is given as equal, they are equal. Range is u square sine 2 theta by g, and h max is u square sine square theta by 2g. Sine 2 theta can be written as 2 sine theta cos theta, so it will be u square by g 2 sine theta cos theta is equals to u square sine square theta by 2g. So u square will get eliminated, g will get eliminated, 1 sine theta will get eliminated. So we can say tan theta comes out to be 4. So option 1 is the right answer. Now let us see this question. Given below are two statements. One is assertion, other is reason. Assertion is when a body is projected at an angle of 45 degree, its range is maximum. So that is correct. So for maximum range, the value of 2 theta should be equals to 1. So that is fine. So we can say both A and R are correct, and R is the correct explanation of A. So option 2 is the right answer. The equation of projectile projected from the ground is given by y equals to x minus x square by 20, where x and y are measured in meters. The maximum height attained by the projectile. Now we have to compare, this is the equation of trajectory. Let us compare this with the general form. So y is equals to x tan theta minus g x square upon 2 u square cos square theta. Now if we compare the coefficient of x, so coefficient of x is given as 1. Here we have tan theta. So it means tan theta is 1. So theta is 45 degrees. Now let us compare the coefficient of x square. So 1 by 20 is equals to g by 2 u square cos square theta. Right? And we have to find the maximum height attained. Now from this, I'm taking g as 10. So this will give us 10. So u square and theta is 45. So cos square theta will be 1 by 2 equals to 100. So u comes out to be 10 root 2. Now let us find the maximum height. So h max is u square sine square theta by 2g. So that will be 200 1 by 2 divided by 20. So that will be 10. So it comes out to be 5 meters. So option 1 is the right answer. Now let us see this question. Two projectiles A and B are thrown with initial velocity 40 and 60 meters per second at an angle of 30 and 60 with the horizontal respectively. The ratio of their ranges. We know that range is given as u square sine 2 theta by g. So and they have different velocities, so r is proportional to u square sine 2 theta. So we can say r1 by r2 will be equals to u1 by u2 square times sine 2 theta 1 by sine 2 theta 2, right? Let us substitute the values. So u1 is given as 40, u2 is given as 60. Sine 2 theta will be sine 60 degrees and sine 2 theta 2 will be sine 120 degrees. So this will give us 4 by 9. And sine 60 is root 3 by 2, and sine 120 is again, it will be root 3 by 2. Clear? And that comes out to be 4 by 9. So option 4 is the right answer. Clear? So okay, right. So now let us see the next problem. Two projectiles are projected at 30 and 60 with the horizontal with the same speed. The ratio of their maximum height attained by the two projectile. So we have to find the maximum height. So h max is given as u square sine square theta by 2g. For the same speed, h max is proportional to sine square theta. So h1 by h2 will be sine theta 1 upon sine theta 2 square. Sine theta 1 is sine 30 and sine theta 2 is sine 60, square of that. that will be 1 by 2 root 3 by 2, so it will be square of that 1 by 3. So option 3 is the right answer. Now let us this question. The range of the projectile projected at an angle of 15 degree with the horizontal is 50. If the projectile is projected with same velocity at an angle of 45 degree with the horizontal, the range will be. Now we know that range, same velocity is given. So range formula is u square sine 2 theta by g. So for a given speed, range is proportional to sine 2 theta. So we can say R2 by R1 will be equals to sine 2 theta 2 by sine 2 theta 1. So we have to find a range when the angle of projection is 45. So R1 is given as 50 meters and sine 2 theta 2. So that will be 90 degrees and 2 theta 1 will be 30 degrees. So R2 comes out to be 100. So option 3 is the right answer. Now let us see this question. A projectile is projected at 30 degrees with the horizontal with initial velocity of 40 meters per second. Velocity of projection at t equals to 2 seconds from the start will be. So we know that velocity is given as u cos theta I cap plus u sine theta minus gt j cap. So we're going to use this. So initial velocity is 40, the angle is 30, so it will be root 3 by 2 I cap plus 40 and sine 30 will be 1 by 2 minus 10 times 2. So this will be 20 root 3 I cap plus 20 minus 20 j cap. So it is 20 root 3 I cap. So the speed velocity of the projectile after 2 seconds will be 20 root 3. So option 1 is the right answer. Okay, right. So a projectile fired at 30 degrees to the ground is observed to be at the same height at time 3 seconds and 5 seconds after projection during its flight. The speed of projection of the projectile is in meters per second. Right. So if I show you the trajectory, suppose we have launched the projectile with initial velocity u and the angle of projection is 30 degrees and it is at the same height. Let us say this is the height, right? At 2 instants. And we have to find the speed of the projection. So let us say this height is h. So if you apply equation of motion in vertical direction, so sy is equals to uyt plus half ayt square, right? So from this sy is h and uy is velocity in the vertical direction, so u root 3 by 2, sorry, u times 1 by 2 minus half g t square. Got it? So we got a quadratic in time. So from O to A the time is 3 seconds and from O to B the time is 5 seconds. So now from this it can be written as g by 2 t square minus u by 2 t plus h equals to 0. So t1 plus t2 will be minus b by a, that will be u by 2 divided by g by 2, and t1 t2 will be c by a, which will be h divided by g by 2. Now t1 and t2 is given to us, so 8 is equals to u by g and t1 times t2 will be 15, will be equals to 2h by g, right? Now from this equation we can find the speed of projection, which comes out to be 80. So u will be 80 meters per second, right? Now let us say this question, a body is projected from ground at an angle of 45 degree with the horizontal. Its velocity after 2 seconds is 20 meters per second. The maximum height reached by the body during its motion. So we have given angle of projection which is 45 degrees and we have given velocity after 2 seconds is 20 meters per second. So V is u cos theta I cap plus u sine theta minus gt j cap, right? So velocity is given as 20. So u, it will be u by root 2 I cap plus u by root 2 minus 10 times 2 j cap. Now its magnitude is given as 20 meters per second. So u by 2, u by root 2 square plus u by root 2 minus 20 square, root of that is given as 20. So u square by 2 plus u square by 2 plus 400 minus 40 u by root 2 is given as 400. So this 400 will get eliminated. So we got u square minus 40 u by root 2 equals to 0. So u will be 0, or it can be 40 by root 2, or it can be written as, so we can ignore 0. So u comes out to be 40 by root 2 times root 2 by root 2. So that will be 20 root 2 meters per second. Now we know what is the speed of projection. So h max can be written as u square sine square theta by 2g. So u square will be 400 times 2, and sine square theta will be 1 by 2 divided by 20. So it gives us 20, right? So maximum height will be 20 meters. Now let us say this question. A fighter jet is flying horizontally at a certain altitude with a speed of 200 meters per second. When it passes directly overhead an anti-aircraft gun, bullet is fired from the gun at an angle of theta with the horizontal to hit the jet. If the bullet speed is 400 meters per second, the value of theta will be. So we have given a fighter jet, and when this fighter jet is overhead an anti-aircraft gun, a bullet is being fired, right, by the anti-aircraft gun. So it has a velocity of 200 meters per second in the right direction, and it is being fired at an angle of theta, and the bullet hits the aircraft. So this is the trajectory of the bullet, and somewhere here it hits the aircraft. Okay, so when this thing can happen? Only if their horizontal components are equal, right? Horizontal component of velocity components are equal. So if the velocity of projection of the bullet is v, so v cos theta should be equals to 200, and bullet speed is given as 400. So 400 cos theta is equals to 200. So cos theta will be 1 by 2. So theta will be 60 degrees, right? So 60 is the answer of this question. A projectile is launched at an angle alpha with the horizontal with a velocity 20 meters per second. After 10 seconds, its inclinations with the horizontal is beta. The value of tan beta will be, right? So let us see. So we have launched a projectile with initial speed of 20 meters per second at an angle alpha. And after 10 seconds, its inclination becomes beta. So this becomes beta and velocity becomes v. So we have to find tan beta. So first of all, we know in the horizontal direction there is no acceleration. So 20 cos alpha should be equals to v cos beta. And in the y direction, and this happens after 10 seconds. So if you apply equation of motion in y direction, so vy, which is v sine beta, equals to uy, which is 20 sine alpha minus gt, and t is 10 and g is also 10. So this will become 100, right? 10 times 10. So we got v cos beta, v sine beta. So v cos beta is 20 cos alpha, v sine beta is 20 sine alpha minus 100. And we have to find tan beta, right? So let us take the ratio of these two. So tan beta is 20 sine alpha minus 100 divided by 20 cos alpha. So this will give us 5 here. So it will be tan alpha minus 5 secant alpha. So tan alpha minus 5 secant alpha. So option B is the right answer. A person can throw a ball up to a maximum range of 100 meters. So what is the maximum range? It is u square by g. So that is given as 100. how high above the ground he can throw the ball. So this will give us the max. So from this we can find the speed of projection. So u will be what? It will be root of 1000. So with this speed, if you're throwing the ball in the upward direction, the maximum height will be, so we can so that will be, so if you apply the third equation of motion, so final velocity will be 0, initial velocity is u minus 2a will be g times maximum height. So h max will be root 1000 square by 2g, that is 20. So 1000 by 20, so that will give us 50 meters. So option B is the right answer. Now let us see this question. A ball is projected from the ground with a speed of 15 meters per second at an angle of theta with the horizontal, so that its range and maximum heights are equal. We have done the same question. The option D is the right answer. This the same question we have done, right? So you can do this as a homework. Answer option 3 is the right answer for this. Two projectiles thrown at 30 and 45 with the horizontal reach the maximum height in the same time. The ratio of their initial velocity. Okay, right. So they're reaching the maximum height in the same time. So it means the time of flight will be same. So t1 will be equals to t2. Because the time of ascent is same as time of descent, so we can say the time of flight will be same. So it will be 2 u1 sine 30 degrees by g should be equals to 2 u2 sine 45 degree by g. So 2 by g will get cancelled out. So u1 by u2 will be sine 45 by sine 30. So 1 by root 2 by 1 by 2. So that will be 2 by root 2, or it will be root 2. So root 2 ratio 1. So option 3 is the right answer. So if the initial velocity in the horizontal direction of a projectile is unit vector I cap, and the equation of trajectory is this, y equals to 5x times 1 minus x, the y coordinate component of the vector of the initial velocity. So we have to find the y coordinates. So what we can do, so we have y is equals to 5x minus 5x square. So dy by dt will give us the y coordinate, that will be vy, and dx by dt is the x coordinate, which is given as 1. So if you differentiate this with respect to time, so dy by dt is equals to 5 times dx by dt minus 5 times 2x dx by dt. And initial velocity they're talking about, so x will be 0 initial for the point of projection. So this term will become 0. So 5 times dx by dt, which is 1, so it will be 5, right? So 5 is the answer of this question. A body of mass 10 kg is projected at an angle of 45 degree with the horizontal. The trajectory of the body is observed to pass through the point 20, 10. If t is the time of flight, then its momentum vector at time t equals to t by root 2. So if we want to find the momentum, we need to find the velocity, right? So once we know the velocity, we can multiply that with mass, we'll get the momentum vector. And it is passing through 20, 10. So an angle of projection is given. So let us use this formula. So let us use the equation of trajectory. So y is equals to x tan theta minus g x square upon 2 u square cos square theta. So theta is given as 45 and it is passing through 20, 10. Let us substitute y as 10, x as 20. So y is 10, x is so y is 10, x is 20, and tan 45 is 1 minus 10, x is 20, so 400 divided by 2 times u square times cos 45 is 1 by 2. Cos square 45 is 1 by 2. So from this we will get 10 equals to 4000 by u square, or u square will be 400, or u will be 20 meters per second. Now we know the speed of projection, and we have to find the momentum vector at t equals to t by root 2, where capital T is the time of flight. Now time of flight is 2u sine theta by g, so that will be 2 times 20, and sine 45 is 1 by root 2 by 10, so this comes out to be 4 by root 2, or we can write this as 2 root 2. So that is the time of flight. So t by root 2 is nothing but 2 seconds. So that is t. So what is the velocity after 2 seconds? So v is u cos theta I cap plus u sine theta minus gt j cap. So let us substitute the value. So u is given as 20, cos 45 is 1 by root 2, I cap plus 20 by root 2 minus 20 j cap. So we got the velocity. Now let us multiply this velocity with mass. It will give us the linear momentum or momentum vector. So it will be, mass is given as 10, so 200 by root 2 I cap plus 200 by root 2 minus 200 j cap. Okay, so let us simplify this. So 200 by root 2 will be common. Okay, right. So let me simplify this. Let us write let us rationalize the denominator. So we can write this as root 2 100 root 2 I cap plus 100 root 2 minus 200 j cap. So that is the momentum vector. So if you look at the options, option D is the right answer. Now let us see the next question. A ball of mass m is thrown vertically upward. Another ball of mass 2m is thrown at an angle theta with the vertical. Both the ball stays in air for same period, so they have same time of flight, and the ratio of the heights attained by two balls is 1 by x. We have to find the value of x. So let us see both the situation. So we have given a ball and it is being thrown in the upward direction. Let us say it is being thrown with the speed u1, and there is another ball which is being thrown with the same say the speed is u2 and the angle of projection with the horizontal is theta. It is having a mass m, this ball is having a mass 2m, and we have given both the ball stays in air for the same amount of time, so it means the time of flight is same. So what is t2? So t2 is 2u2 sine theta by g. Now in case of the first ball, the time of flight will be 2 u2 by g. u1, sorry, not u2, it will be 2 u1 by g. And we have given that the time of flights are equal. So t1 is equals to t2. So we can say 2 u1 by g is equals to 2 u2 times sine theta by g. So g will get cancelled out, 2 will get cancelled out. So u1 by u2 is nothing but sine theta. So we got this relation. And we have to find the ratio of the heights attained by the two balls. So let us do that. So h2 will be u2 square sine square theta by 2g, and h1 will be u1 square by 2g. Now if you take the ratio, so h1 by h2 will be u1 square upon u2 square sine square theta, and u1 by u2 is given as sine square is sine theta, so that is nothing but 1. So x will be 1, right? So that is the answer. Now let us the next question. Based on the same problem type, an object is projected in air with the initial velocity u at an angle theta. Okay, one thing I think I have taken theta with the horizontal, it should be with the vertical, right? So wherever I have written theta, it should be 90 minus theta. Let me correct that. So this should be 90 minus theta. This is also 90 minus theta. 90 minus theta. Okay, so we'll get the same answer even in this case. An object is projected in the air with initial velocity u at an angle theta. The projectile motion is such that the horizontal range is r is maximum. Another object is projected in air with a horizontal range half of the range of the first object. So when do we get maximum range? When theta is 45 degree. So in the first case, theta will be 45 degrees and we are getting maximum range. Initial speed is u. Now another body is projected in air with the horizontal range half. So let us say this is r1 and r1 is u square by g. So that is r1. Now the second body is being thrown such that we are getting half of the range. So this is r2 and r2 is r1 by 2. The initial velocity remains same in both the cases. So this particle is also projected with the same velocity. Initial velocity. The value of angle, okay, right, so it should be initial speed, right? Not velocity. Initial speed remains same in both the cases. So this angle will be theta. The value of the angle of projection at which the second object is projected will be, right? So R2 will be u square sine 2 theta by g, and that is equals to u square by g times 1 by 2. So u square by g will get cancelled out. So sine 2 theta comes out to be 1 by 2. So it means 2 theta is 30 degrees. So theta comes out to be 15 degrees. So 15 degrees is the answer of this question. Now let us see this question. A projectile motion of a particle of mass 5 grams is shown in the figure. The initial velocity of the particle is 5 root 2 meters per second and the air resistance is assumed to be negligible. The magnitude of the change in momentum between the point A and B is x into 10 raised to the power minus 2, the value of x to the nearest integer. So we have to find the change in momentum between B and A. So just before hitting the ground, the speed will be same as the speed of projection. So here, if the speed is 5 root 2, then just before hitting the ground, the speed is also 5 root 2. So the final momentum, so I can say this is the final or momentum at B, which is making an angle of 45 degree with the horizontal. And we have to find change. So PB minus PA, that is the change. And this is PA, which is making an angle of 45 degree with the horizontal. And we have to find PB minus PA, which can be written as PB plus minus of PA. So minus of PA will be opposite to PA. This is minus of PA. Now the resultant of these two vectors, minus PA and PB, will give us the change in momentum. So this is the change in momentum delta P. And this angle will be 90 degree, right? This total angle will be 90 degrees. So delta P will be what? It will be 2 times, say, PA times cos 45 degrees. Because PB and PA both have the same magnitude. So 2 times mass is 5 grams, so 5 by 1000 times the velocity, that will be 5 root 2. Cos 45 is 1 by root 2, so root 2 will get cancelled out. So this will be 50 by 1000, which will be 5 into 10 raised to the power minus 2 kilogram per meter per second. So x will be 5. So 5 is the answer of this question. Now let us see this question. A stone is projected at an angle of 30 degree to the horizontal. The ratio of the kinetic energy of the stone at a point of projection to its kinetic energy at the highest point. So at the highest point, velocity is u cos theta. And at the point of projection, velocity is u. So we have to find the ratio of kinetic energy at the point of projection. So which is half mu square to the kinetic energy at the highest position, which will be half m u cos theta square. So this comes out to be 1 upon cos square theta, and cos 30 is root 3 by 2, so that will be 4 by 3. So option 4 is the right answer. Right, now let us see this question based on the same problem type. Two objects are projected with the same velocity u, however at different angles alpha and beta with horizontal, and alpha and beta are complementary. The ratio of the horizontal range of the first object to the second object. So when we have if we are projecting particle with complementary angle, keeping the speed same, then the range will be same, right? So it should be 1:1. So option 4 is the right answer. Now let us see the next question based on the same problem type. The trajectory of the projectile in a vertical plane is given as y equals to alpha x minus beta x square, where alpha and beta are the constants, and x and y are respectively the horizontal and the vertical distances of the projectile from the point of projection. The angle of projection theta and the maximum height attained are respectively given as. So let me rewrite the equation of trajectory. So that will be y is equals to x tan theta minus g x square upon 2u square cos square theta. So that is the general equation or general equation of trajectory. Now let us compare this equation with the given equation. So we can clearly see that tan theta is nothing but alpha, coefficient of x should be same, and coefficient of x square should also be same. So beta should be equals to g upon 2u square cos square theta. Now theta comes out to be tan inverse alpha. So it means option 2 and option 4 are incorrect, and we have to find the maximum height. And cos square theta is g upon 2u square beta. So h max is u square sine square theta by 2g. So this will be u square by 2g, and sine square theta is 1 minus cos square theta. So 1 minus g upon 2u square beta. So I've used this value, right? And tan alpha, tan theta is, okay, right. Maximum height you have to calculate, right? Tan alpha, right? So if you look at the option, it says alpha square by 4 beta. Let me first calculate that. Alpha square by 4 beta. So alpha square by 4 beta will be tan square theta divided by 4 beta will be g by 2u square beta g by 2u square, and then we have cos square theta. So this will be how much? So this will give us 2. So it will be u square sine square theta by 2g, right? So it means option 1 is the right answer. Now let us see another question. The maximum vertical height to which a man can throw a ball is 136 meters. The maximum horizontal distance up to which he can throw the ball. Similar question we have done, right? So you can, I'm keeping this as a homework. So if you do that, if you try to solve this, you will get option 3 as the answer. Okay, right. So for a body projected at an angle with the horizontal from the ground, choose the correct statement. So gravitational potential energy is maximum at the highest position. So that is correct. The horizontal component of velocity is 0 at the highest position. That is incorrect. It is u cos theta. The vertical component of momentum is maximum at the highest position. That is 0. So this is incorrect. The kinetic energy is 0 at the highest point of the projectile motion. That is incorrect. It is half m u square cos square theta. So option 1 is the right answer. Now let us see the next problem type where we are projecting particle from some certain height horizontally. So let us see this question. A ball rolls off the top of the stairway with a horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide, and the minimum velocity u with which the ball just hits the step 5 of the stairway will be root x meters per second, where x is. So we have given a staircase like this. Right, so we are throwing a ball horizontally with a certain velocity u, and this height is given as, so height of each step is given as 0.1 meter, and the width of each step is given as 0.1 meter. And we make sure this ball hits the fifth floor or fifth step. So that is the fifth step, right? So this one is the first one, this is second, this is third, fourth, and fifth, right? So what should be the minimum velocity? So if we are able to make sure this particle just hits this particular edge, okay, so we can say this will be the limiting case. So in this case, what is the horizontal displacement? We can say it will be 4 times, that will be 0.4 meters, and the vertical displacement will be 0.4 meters. Now what we can do in this case, we can use equation of trajectory in case of a projection from a height horizontally. And how we can do that? If I assume horizontal as the x-axis and vertical as the y-axis, then x can be written as ut and y can be written as half gt square. So if we eliminate time from these two equations, we will get the equation of trajectory. So y is equals to g x square by u square by 2. So that is the equation of trajectory. And if you look at this particular point, its coordinates are 0.4 comma 0.4. Now let us substitute these coordinates in the equation of trajectory. So it will give us 0.4 is equals to g, which is 10 by 2 times 0.4 square divided by u square. So this will get cancelled out, and this will give us a 5. So u square will be 2. So u will be root 2, and this is given as root x. So x is nothing but 2. So 2 is the answer of this question. Now let us see this question. Based on the same problem type, a body of mass capital M throws horizontally with a velocity u from the top of a tower of height h touches the ground at a distance of 100 meter from the foot of the tower. So we have given a tower and we are throwing a ball of mass m horizontally with a velocity v, and the height of the tower is given as h. And right, so its distance, so the range touches the ground at a distance 100 meters from the foot of the tower. So that is the range for the first particle or first body. A body of mass 2m throws with a velocity v by 2 from the top of a tower of 4h, right, will touch the ground at what distance? Okay, let us see. So in case of a horizontal projection from the height, the range is given as the velocity of projection times the time of flight, which is 2h by g, right? So we can say the range is directly proportional to velocity and directly proportional to square root of the height of the tower. So we're going to use this. So we can say r2 by r1 will be equals to v2 times root h2 divided by v1 times root h1. So r2 we have to calculate. R1 is given as 100. V2 is v by 2, v1 is v, and h2 is 4 times h, and h1 is h. So this will give us 1. So range will be 100 meters. So there is no change in the range. It will remain same, right? So 100 is the answer. Now let us see this question based on the same problem type. A child stands on the edge of the cliff 10 meters above the ground and throws a stone horizontally with an initial speed of 5 meters per second. Neglecting the air resistance, the speed with which the stone hits the ground is. So height is given. So again, this question can be solved in multiple ways. So here you can also use energy conservation because the stone is coming down by a height h, there will be a loss in gravitational potential energy, and that loss has converted into kinetic energy. So we can say half mv final square minus half mv initial square will be loss in gravitational potential energy, which will be mgh. So this we can apply, so m will get cancelled out. So we find, and we have to find the speed, so vf square will be equals to vi square times plus 2gh. So vi is 5 and g is 10 and h is 10. So it will be 25 times 200 plus 200, which will be 225, and root of that will be the speed just before hitting the ground, and it comes out to be 15 meters per second. So option 2 is the right answer.
तो ये था इस क्वेश्चन का कंप्लीट सॉल्यूशन। अगर आपने ध्यान से स्टेप्स फॉलो किए हैं तो आप सिमिलर क्वेश्चंस भी कॉन्फिडेंटली सॉल्व कर पाओगे। प्रैक्टिस करते रहो, क्योंकि जेईई एडवांस्ड में क्लैरिटी और अप्रोच सबसे इंपॉर्टेंट होती है। अगर वीडियो हेल्पफुल लगा हो तो लाइक करें, अपने फ्रेंड्स के साथ शेयर करें और प्रैगबी चैनल को सब्सक्राइब करना ना भूलें।